Greetings, students, and welcome to another episode of Math with Mrs. D in room 403. Once again, I ask that you find yourself a distraction-free zone where there are no interruptions. Make sure you have a pencil and that note-taking packet, which comes back to school every day. You can pause and watch these videos more than once, and it's a good idea to pause so you can take your notes. If there is a response link in Google Classroom at the end, please finish that and submit it. Our goal for this lesson is that in the end you will know what a square number is and how to tell if a number is a square number. Also that you'll know how a square number can be written in exponential notation, and which calculator key will square a number. Now, I want you to think back to our lesson on rectangular arrays. You should remember that many numbers have multiple ways to draw the arrays that represent the number as a visual. For example, we have 16. 16 can be 1 times 16 as one of its arrays. It can also be 2 rows of 8. And it can also be 4 rows of 4. And if I asked you to take a closer look at that, which one of those is in the array of a square? Yep, that one. So, we should notice that numbers that can be arranged into a square array with equal rows and equal columns is considered a square number. You saw that one of the arrays for 16 was a 4-row by 4-column array. That created the square. So now I'm going to show you in the T-chart how you would recognize this. So you have the number 16 and you list the factors. Apologize for that. That's kind of, oh, it's not going away, so we'll have nice big thick lines here. Let's see if I can make that smaller. Okay. And 2 and 8 and 4 and 4, and then we're back to 8 and 2. Just a reminder that that's where the commutative property starts again. So right there you see that you're going to have equal rows and equal columns. So the T-chart can just tell you that when you see that factor multiplied by itself in order to make one of the arrays, you've got yourself a square. So let's demonstrate that again with 36. You have 1 and 36, because every whole number has 1 as one factor in itself. 2 and 18, 3 and 12, 4 and 9, no 5s, 6 and 6, and then we're back to our 9s. So we can stop there. And right there you see that number 36 is a square number because it has the array that can be built out of equal rows and equal columns. So the T-chart is actually a really good strategy for you to set up your plan to check numbers in case you are wondering if it is a square number or not. Now, you go ahead, set up a T-chart, and you test a number. Just choose any number, work out its factors, and see if you can conclude that it is either a square number or it is not a square number. Alright, so let's summarize. A square number is one that has an array that can be created with equal rows and equal columns. This can be determined when factors are listed, and there is one factor, when multiplied by itself, equals the square number. And our examples are 4 times 4, so the factor 4 multiplied by itself, 4, equals that whole number. You can look at that with 6 times 6, so factor of 6 times itself equals 36. Okay, are you ready to shift gears a little bit? We're still talking about square numbers, but now we're talking about how to write them or show them as a numerical form. So we're going to talk about something called exponential notation. Now, you should notice that the word exponent is in there, and if you've had any work with exponents before, that should prompt you as to what exponential notation is, but let's assume that you don't know what that is. So, exponential notation is basically using an exponent, using an exponent form as a name for the square number. So, like we've drawn pictures and we've written numbers, this is another way to write its name. So an exponent itself is a small number raised slightly next to a factor. The exponent tells how many times to multiply that factor by itself. So we can take a look here. The exponent is this little 2. And it's slightly raised next to the 4, which is the factor. And what it says to you as a person working with math, it says that factor times itself will equal a square number. Looking at the number 6 squared, so we call it 6 squared, says that factor 6 is multiplied by itself. That's what the square does. Now, I do have to point out a misconception. It's very, very, very common for kids to see 3 squared and to automatically jump to their multiplication fact, not their squaring. And what I'm saying is that some kids will see 3 squared and they will automatically think it is 3 times 2. This is a multiplication fact. This is a square. This is not 3 squared. So let's take a look. What if I said 6 squared? Would it be 6 times 2, or would it be 6 times 6? It's not 6 times 2. That's a basic fact. This is 6 squared, or 6 to the second power. There's your 2 powers multiplied by themselves. Now, calculators are meant to speed up processes, and the calculator has a button. It depends upon which calculator you have. There are different buttons, and I'll talk about the 2 most common ones that we will be working with. So you have a calculator, and the keys that will square a number are the caret, which is, I'll just draw it down here. Caret is basically a pointer or an upside down V, so it's kind of pointing like, hey, raise it up there. So it's pointing up a little bit. So we see 4 squared, or 4 to the second power. So we take 4, and then you tell the calculator, raise it to the second power. And it does that. It takes 4 times 4, which we learned in the last slide was 4 to the second power, or 4 squared. If you're dealing with 6 squared and you have a different type of calculator, you might, for whatever number, it doesn't have to be 6 squared, but whatever your factor is, you would put in that factor, and then you would tell the computer by using the button that looks like this. X means you can put whatever number here you're given, and it's going to square it for you. So it's going to do the job of multiplying it by itself. So let's see how that looks with our T-charts, because our T-charts are a fantastically organized strategy. If we are working with the number 16 and we list its factors and we get to the point where we know, hey, this is a square number, and you want to use your calculator key, you would 4 times 4 we know is 4 squared, and into your calculator you would first push the factor 4, then you would push the caret button, which tells it to raise it to the power of whatever you put here, and in this case it's 2 because we are squaring. If it were a 3 here, we would call it cubed, so it would be 4 to the power of 3, but we're just dealing with square numbers today. Again, with 36, we recognize that it is a square number, equal rows, equal columns, and that number can be written as 6 to the power of 2, basically taking its factors and multiplying them by themselves. Into the calculator, you would press the whole number 6, and then you would press the key that says x squared, or x to the second power, and it would calculate that for you. Well, you have completed another session of our math videos. You rock. Super awesome. See you tomorrow.